question 5. Now, there's a lot of marks going here, but basically this is all really to do with just getting your diagram sorted. Okay, once your diagram's sorted, as you can see, the actual calculation is pretty brief, but you've really got to get your mind around the forces. So I think when you've got an inclined plane, it's always best to resolve either perpendicular to the plane or parallel to the plane. So I'm going to get all my forces such that they're broken down to either being diagonally upwards or downwards like that, or diagonally upwards or downwards against the slope. So popping all our forces in. So starting off, I've obviously got the weight going straight down from P. So the weight straight down is 2g, but breaking that down into its two components that are parallel or perpendicular to the plane, I've got 2g cos 20 being this component here going downwards, and this component here being 2g sin 20. So just check you're okay with that. Because this is 20 degrees and this is 90, this must be 70, and because these two together form a right angle, that must be 20. So that's where that 20's come from, and this is adjacent to that, so that's 2g cos 20, and that is opposite to the 20, so that's 2g sin 20. So I've broken my weight component there in blue down into these two red components. Now my normal reaction is just going up perpendicular to the plane, calling that R. Now I'm being told that the P is on the point of sliding up the plane. So the direction of motion would be up the plane, so the friction would be down the plane. So make sure you got your friction going downwards, and that is mu times whatever the normal reaction happens to be. And then the only other thing I need to do to make sure all my forces are broken down to either being parallel to the plane or perpendicular to the plane is to break down this 40 newtons here. So breaking that down into this component and this component, we have this being 40 sin theta, obviously that's opposite to the 30 degrees, and this component here in red is 40 cos theta. And again, so just really take your time getting your diagram sorted, put all the arrowheads on, and then I think it's fairly straightforward. So I need to end up resolving up and down the plane, but given that friction is one of the components, I have to kick off by resolving perpendicular to the plane, because I'm going to need to know what R is, because that's a component of the friction. So resolving up and perpendicular to the plane, I've got my only force going upwards is R, so that's going to equal the two forces going downwards, which are R sin 30 and 2g cos 20. So R equals these two added together, which is about 38.41 newtons. Now resolving up the plane, always resolve well, it doesn't really matter, but I've resolved up the plane. Okay, so my only force going up the plane is my 40 cos 30, and that's going to equal my two forces going down the plane, which are the friction, which is mu times R, which is mu times 38.41, and my other force going down the plane is this 2g sin 20. So taking away 2g sin 20 from both sides, then dividing by 38.41, I get mu being 0.727.